Rates of change. This does not look like fun.
Yeah, rates of change. It is fun. Hey, Rachel.
Hi, Rachel.
Okay, so we're going to do rates of change.
The cake is delicious.
Yeah, good cake. So with rates of change, what we're talking about is how does something change in comparison to something else, right? So really, when we were talking about velocity before, that, velocity, we talked about it being the same as just ds over dt, right? Change in position over time. So that was a rate, right? We're going to just talk about pretty much the same things now, but rates in other contexts. And then we're going to have maybe two different kinds of rates in the later questions. So starting off, let's do this one. So it says a spherical balloon is being inflated. The volume is changing with respect to the balloon's radius. Find the rate of change of the balloon's volume when its radius is 15 centimeters. So what I'd like you guys to start doing is just writing down what your variables are. So there's two variables, V and R.
V is 4 pi r, isn't it?
Right, so those are our variables, those are the things we're interested in. And it's saying what's the volume with respect to. So as soon as it says respect to, we're talking about like d, dr. Respect to the balloon's radius. So that's what we're saying. It's going to be like ddr. Does that make sense?
Sure.
Yeah? Maybe it'll make a bit more sense here in a second. Okay, so the equation that relates volume and radius is going to be volume is equal to 4/3 pi r cubed. And now really all we got to do, if we want to figure out rate, what we want to figure out is rate of volume is really just going to be dV over dr. That's our goal. Whenever we say rates, we're talking about the derivative of something over something else.
Now we know.
Now we know. Okay. So if we go a little farther with this, so dV over dr, if you think what we're really doing is we're going to take ddr of this whole thing. And that becomes dV over dr, which is what we're looking for, is equal to, scroll up a little bit. So that was this part, took the derivative of it. Now take the derivative of that part. So that's going to be 4/3 pi and then 3 times r squared. My 3's cancel, and I end up with dV over dr is equal to 4 pi r squared. And we knew that r was equal to 15 centimeters at this point, right? So all we got to do now is plug that into r. And if we do that, the rate at which the volume is changing is going to be 4 pi times 15 squared, which is equal to 900 pi. And my units would be centimeters cubed per centimeter.
That is stupid.
Does that make sense?
No.
Because it's saying the volume is changing, so the volume is on top per radius, because radius is measured in centimeters. So as the radius increases, what does the volume do?
900 pi.
Okay, let's move on to the next one. Okay, population growth, 1. So it says the population of bacteria culture after T hours is given by this formula. What are we probably going to have to do with that formula? Probably going to take the derivative, yeah. Where T is time in hours. So A says find the rate of growth after 5 hours.
And you can throw 5 in there.
Yep, exactly. So the first one, all we got to do is throw 5 into that. So the rate of no, we can't just throw 5 into
no,
that.
500 equals.
Right, because N is going to give you how many there actually are, right? After that much time. We want the rate of growth. So the rate. So when it says that, for A, what we want is d dt. So we're going to find that pretty much all these rate questions are going to be over time, like how is something happening over time.
We want harmful chemicals?
DDT, yeah.
Okay.
Okay, so
Rachel's gonna shake her head when she watches this.
probably. Okay, so what we gotta do is take the derivative of this with respect to time, right? D dt. So d n dt is equal to 200 minus 24t. Now we just sub in. So n prime, same thing, right? Is that n prime at 5 is going to be 200 minus 24 times 5. Oh, that was weird. Brain glitch. And at 5 prime is equal to 80. And then bacteria per hour, because it's a rate that we just figured out.
Slow growing fungus.
Is the population increasing or decreasing?
I'm gonna say increasing because it's positive. And I don't want to do more than that.
Yeah, population, so this is really B here. Population is growing, the rate of growth is positive.
Ours doesn't say that.
Yeah, so write that down. Okay, C was what's the maximum population of the culture? So remember those maximizing area problems we have?
500 because it's 500 equals something.
What?
The equation is 500 equals 200t minus 12t squared, so isn't that the maximum?
Oh, that should be, oh weird. That should be minus, I think. Minus or plus, that's a typo.
Now I'm thoroughly confused.
Are you? Because...
Wait, no, just the other way.
All right, Rachel, there was Rachel, there was a typo up there. That should be positive. 500 plus 200t.
I'm fixing it on your booklet. You're welcome. I'll send you the bill.
Okay, C says what's the maximum population of this culture? So if you think about it, it's going to look something like this, right? So what would the derivative be, or what at that very top point is what we're looking for, right? What would the derivative be equal to there?
0.
0, right? We're looking for the slope at that point. So we need to make our derivative just equal to 0. So that's going to be 0 is equal to 200 minus 24t. So now we can find the time. But then the question says, what is the max population? So as soon as we find the time, then we're going to plug t back to the original, right? So if you solve for t there, we end up with t is equal to 25 over 3 hours. Now if I plug that back into my original formula, we'd have n of 25 over 3 is equal to 500, and yeah, what's plus? 200. 25 over 3 minus 12, 25 over 3 squared is equal to 1,333. Okay, Rachel, so though this is where you guys would do your this homework question, but since we're like in fast forward, I'd like you guys, I'm just going to keep on going. In the next video, I'll end this video here and start a new one, but that's going to be part of your homework.
Bye, Ray.